Has anyone heard of the company LeSEE? They write like Le-Eco. You haven't. I hadn't heard of them up until a couple of years ago, as my boss, the CEO of Aston Martin, came from his China visit. Absolutely, we thought he was brainwashed. He took his iPhone, put his on a desk in a boardroom, and referred to it as a crap. Please don't quote me, but he was so impressed by the advance of technology in China and by the advance of the technology brought by one company, who later became a partner with Aston Martin. That company is LeSEE. And I'd like to introduce Kai Ni with the news article. LeSEE accelerates its smart electric vehicle plans, hires scientists from China's autonomous driving guru. After announcing a partnership with Aston Martin at CES 2016, LeSEE has now appointed Mr. Kai Ni to drive the smart driving division of LeSEE. Please welcome Kai Ni.
Thanks for the introduction. I'm very glad to be here. I'm not sure whether I'm the only China speaker here, but today I would like to introduce you some kind of the scenarios we are facing in China and why we think the autonomous driving is so hot and how we should handle it, fortunately, in the kind of near future. So first, I think there's two kind of very hot topics recently. One is the AI, the artificial intelligence, and the other one is the self-driving. And these two topics are actually very close related, as I will discuss in the later slides. They're also very interesting. There are two stocks recently draw a lot of attention from the market. The first stock I want to mention is NVIDIA. I'm not sure everyone is familiar with this company because this is an IT company, not an automotive company. But basically, what the core business of this company is making a GPU. GPU is the core of your graphics card. Everyone who loves to play computer games know you need to buy a really good graphics card. But recently, the focus of this company has changed, and the GPU has been more widely used in the AI domain rather than in the game domain. So recently, the revenue has bumped after the last report. So that's why the stock of NVIDIA has surged since last report. Another company is Tesla, of course. Tesla is so popular now because Tesla becomes the most valued automotive OEM in US. So the original big three has changed. The number one now is Tesla. But if you look at the numbers, in terms of the number of the vehicle Tesla delivers, or in terms of the revenue, actually they are both far behind the GM and the Ford. But the stock market still thinks it has very high potential. That's why the stock price of Tesla is more than Ford and GM, regardless of its actual performance. So that means a lot of attention or interest has been put into this area. Because there's so much attention and so much interest, we can see the trend of this kind of industry. There's new players. Like in the self-driving domain, we know Google start doing this, and Tesla is doing their own autopilot project, and we are doing our own project at FF and LeSEE as well. And suppliers like Mobileye, it's a real company, and they do the front-facing camera and now the surrounding camera. So it basically occupies a lot of kind of market in this specific vertical domain. I think the other thing is that there's a lot of new capital trying to enter this market. For example, the Mobileye was acquired by Intel at $15.3 billion. So this is a huge number, which means the potential of this market. And besides the investment market, there's also new alliance appeared between the new companies and old players. For example, Mobileye, Intel, and BMW. They kind of created this kind of alliance. Recently, Bosch and ZF also created another alliance. So this kind of alliance helps reform the kind of the industry and help the different players try to contribute their own technology into the self-driving product. Besides those big players, there are a lot of new startups as well. Almost all the startups are working on those kind of small areas. For example, sensors, including cameras and LiDARs. Then also people working on the level 4 and level 5 self-driving. Like previously Google self-driving, now known as Waymo, and also Rooks, which is also a Silicon Valley company. Then people working on the level 4, level 5, then also other people working on the low-speed vehicles. So they not do like point A to point B on the map anywhere, but they only do a fixed route, low-speed vehicles. So this is another way to kind of handle the market. And we are also looking at the maps and the chips companies. So we will probably introduce a little bit more later. And now let's look at what kind of problem we are trying to solve in China. If you ask everyone who is working on the self-driving area, I think they will tell you the first task they want to do, or the dream they want to achieve, one of them is the safety. Because this is one of the main reasons we are doing self-driving. But if you ask me why the self-driving is still not on the market, it is because the safety prevents the self-driving technology widely applied to all the products. So on the right, this is a video from the last year, which is right before the Spring Festival, which is almost like a Christmas in Western world. And there's kind of this very bad event happening and impact very many families. And we believe self-driving and ADAS technology is the way to kind of avoid a lot of this kind of mistakes or problems. But really, on the market, we cannot really have a lot of advanced products right now. The best product you can buy now on the market is basically level 2.5 self-driving system. And the self-driving system is divided from level 0 to level 5. So we can only buy level 2.5 system. And Tesla is one of one of these kind of products. They are autopilot. And these two accidents are very similar. Basically, the problem is the vehicle cannot really precisely detect the obstacles surrounding itself. But if you look at the problem from the high level, actually the system is composed of 4 modules, the main modules in terms of software. One is the perception. It basically tells the computer or the vehicle where are the obstacles, where are the lanes, where are the pedestrians. And the second one is the localization. So given the knowledge of your surrounding vehicle, and then you need to know where am I on the map. And the third one is the planning. So you know your location and you know your surrounding vehicles. Now given point A and point B, so the goal of the planning and control module is to drive the car from point A to point B. And the control module really is to take the output of the planning module and convert it to acceleration, deceleration, and steering, basically. That's the kind of the whole idea. And I think the main kind of the most challenging part of these 4 modules, one is the perception. Why the perception is so challenging? Because we have a lot of sensors, but none of them are really good, are perfect. So that's why we have to use a combinations of those sensors to solve our perception problem. I list some of the kind of the representative sensors here. For example, like radar, camera, and the LiDAR. So LiDAR is a very hot topic right now, but LiDAR also has its kind of main disadvantage. It's very expensive, and its resolution is not as high as camera. And when it rains or there's a lot of LiDARs on the road, it will kind of influence each other. So this kind of impact of the one sensor decides that we cannot really only use one sensor to solve the self-driving problem. And this is the sensor configuration of the Tesla Autopilot 2.0 system. And if you look at it, actually it was composed of the 8 cameras and just one radar and all the other ultrasonic radars. So the main kind of the sensor ability is achieved by the cameras. So this represents one kind of mainstream of this industry. So camera is playing a more and more important roles. Another mainstream of the industry believes the LiDAR will play a lot of roles. And then let's see which mainstream will succeed in the end. But besides those kind of hardwares, we have to consider the roads we are facing, right? Those kind of a very typical scenario in China. So you are facing a lot of cars, and those cars are not exactly are driving as expected. For example, in this video, you see people are coming from emergency lane, and people are coming from the opposite lane. They're trying to turn left, turn right, and everything is blocked. So this is a very typical scenario we are trying to solve in the real world, and which means you cannot really design or implement your system as expected or as allowed by the law. More videos. This video shows something. I mean, even for human drivers, I think it's also a valid challenge. And you are trying to solve this kind of problems with the computers. And those are all real videos captured by the data recorders on the cars from different users. Okay, because of time, I don't want to play all the videos. And the other thing is the bikes. The bikes are also very dangerous, especially on the intersections. Okay, so those are the negative things. But if you look at the positive things, at least there's something which is very inspiring in China right now. So first, China researchers and the government and kind of the whole industry has invested a lot on the AI domain. So we actually publish a lot of papers if you search the term deep learning, for example. So we really invest a lot on this kind of domain. And also, if you look at the numbers referenced by the other researchers, this number is also very high. We are also parsing US become the #1 published papers in the world. Of course, this doesn't mean the AI is kind of China has the top 1 AI, but I'm just saying we invest a lot on this domain, and this will generate a lot of outcomes in the long run. And if you look at the size of the software or the complexity of the software, you will see that actually self-driving car, and this only shows a high-end car, which has an ADAS system, not the self-driving system. And the complexity of this car software is much more higher than the other major systems, such as Boeing 787 or Android or Windows. So those kind of things, people are kind of think, oh, those are complex. But the truth is that the car is even more complex. And even you have the hardware and the software and the sensors, you still need to run everything on an embedded system which qualifies all the regulations of the vehicles. So the embedded system are composed of the 3 major parts. One is the CPU, and for example, you can get Intel, the ARM CPUs. And the second one is the accelerator. NVIDIA, I mentioned, is why it's so popular, the stock price surging, is because their GPU technology is really leading the market. And of course, there's other options like FPGA, but now just the trend is the GPU is kind of a little bit leading. And also then you need real-time OS. There's also different options. Besides that, even you have a lot of sensors, you still need the sensor redundancy. This is not only to make every angle is visible to more than 2 sensors, but also act as a backup. For example, when it rains, the LiDAR doesn't work well on this sensor, and then the camera kicks in and try to power the system. And another thing is like high precision map, and those kind of the technology which here map TomTom in Europe are trying to pursuing really makes a difference in the self-driving domain. The last, probably not the least, is the human-computer interaction. So this is something we are doing in our group. We are trying to use LEDs to interact with different kind of people or pedestrians surrounding vehicles. So even there's no drivers on your seat, the pedestrian will be able to know whether the car is trying to go accelerating or is trying to waiting for you to cross the walker and all the parking scenarios. In terms of strategy, there's kind of two popular strategy in the industry. One strategy is we go directly to the most advanced technology, which is the level 5 self-driving system. And another technology most automotive OEMs trying to use now is to use kind of a generative model and then try to directly, not directly target to a level 5, but from level 2 to level 5. Okay, so find some videos about and things about our group we are doing. So in terms of our vision, so we think first we want to build electric cars, and there's intelligent connect shared systems, and this is kind of another perception of this kind of vision. And then we are using cameras to detect different vehicles, roads, and cars. And we need to the LiDAR and camera to, oh, okay.
Okay, thank you very much. Sorry, we have the government are coming.